Let me start with your problem. Okay, so E1, E2, E3 are linearly independent elements. Okay, show you the basis for the vector space. Next one, well, we know actually these are not equal to each other. We prove this. Why is it? Because these are elements of the vector space of tensor product, basic elements, and they are distinct basic elements. Therefore, this element and this element, if they are all basic elements, then these are also linearly independent. So one of them cannot be written in terms of the other, right? So answer no, because this given EI tensor EJ, I and J from 1 up to N is the basis for this tensor V. Therefore, thus E1 tensor E1, E2 tensor E2, and E3 tensor E3 are linearly independent. So one of them cannot be written as a sum of the other two elements. Right? This is a linear dependence relation. But let me give you another argument. So if you just write this, this is correct because we proved in class that if we have a basis for a vector space, then this kind of products is a basis for the tensor product for this one. If you prove this, but you can actually give another argument. Actually, the argument is the one which is used to show that this is the base. Second solution. Consider the linear map. I use this map to prove that this is the base also. Let's say 5 from V tensor V into K by this formula. So on a product like this, V tensor W, considering the linear map, şöyle yazayım. Okay. For any X star in V star, consider the linear map 5 from V tensor V into K, no, not K, V, given by 5 for V tensor W is just X star of V W. We proved in class that this is a linear map, right? So let me now use this one. Let F star to be the dual of E1 star. Okay, I can choose any vector or covector I want. Let me use this one. Then apply this to this identity. Apply F star to E1 cancel E1, E2 cancel E2 equals E3 cancel E3. Well, so 5 of E1 cancel E1, E2 cancel E2 equals 5 of E3 cancel E3, right? This is a linear map. Its action on this is what? You take F and F is the first element and multiply it with the second element. So action of this on this one is what? E1. X star of E1 plus X star of E2, and this is X star of E3. Aslında şeye bile gerek yok da. Neyse. Okay. This is one because X star is just E1 star. E1, E1 star E2, E3 E1 star E3. Well, what is okay now? What is this? This is just right. This is just 1 times E1 plus 0 times E1, E2, and 0 times E3. So it is just right. It is 1 times E1, 0 times E2 equals 0 times E3. So this means E1 is equal to 0. But that's a contradiction, right? E1 is a basis element and it cannot be 0. It is a contradiction. Evet. Yaratıcılığınız. Sonuçta 3-5 tane teknik var. Yani çok öyle yaratıcı olmanıza da gerek yok. Yani ispatlarda kullandığım birkaç tane değişik şey var. Onları bilin yeter. Hani ben sizden sınavda böyle tamamen hiç görmediğiniz bir şeyi akıl edip kullanmanızı beklemem. Derste ne yapıyorsam onun da basit hali. Tamam mı? There is a related question I gave you as an exercise. It is from the book, but the question actually I made a typo. This is not the question in the book. I wrote something similar to that, but the one I put on the exercise sheet is harder. Let me solve the simple one, and then I'll leave the other one to you. Okay. So this is question 5 in exercise sheet 3. Exercise sheet 3. So it is this one. A, B are some elements of a vector space. They are different times 0. And they satisfy this. A cancel A plus B cancel B is equal to U cancel or V cancel W. V cancel W for some D U in V. Suppose A and B are such vectors. The conclusion is that prove that A and B, okay, A and B are linearly independent or linearly dependent. Then in the question I gave you, I said U and no, D and W are linearly dependent. That's also true, but it is you have to do more work to prove that. Okay, now this is easy, and there is a hint in the book, right? There is a hint in the book. What is the hint? Now suppose that this is not true. It means that we assume A and B are independent. So assume on the contrary that the questions I ask here are not typical exam questions because, you know, this is an exercise. You have days to solve and work on these problems. In the exam, I will ask much simpler ones, but you have to understand basic ideas, okay? Basic definitions. You have to know the definitions and you have to know the ideas. But, you know, the ones here are usually difficult questions, okay? They are not suitable for exam. So you shouldn't take this as a, you know, sample test or something. And this, you know, has even some hints in the book, right? Assume that on the contrary, that A and B are linearly independent. Lineer bağımsız ne demek? If they are linearly independent, then I can do the following. I can extend this linearly independent set to a basis, okay? Well, you may say that, how do you know that this is finite dimensional, right? If it is infinite dimensional, but you can do the following trick. You know, what are the vectors you are given in this example? A, B, and W. So 4 different vectors. Maybe some of them are the same. 4 vectors. You may consider the subspace spanned by these 4 vectors. It's a finite dimensional vector space, and you can work on that one. You don't have to work with all the vectors. Okay? So replacing this vector space, if necessary, by the vectors spanned by A, B, D, and W, you get a vector space of dimension at most 4. And I can work in that vector space, subspace. Therefore, I can assume that V is finite dimension. So without loss of generality, we may assume that V is finite dimensional. Well, what happens if it is finite dimensional? Well, then choose the basis for D of the form shown. First vector is A, E1 is the first vector, E2 is the second vector, which is B, and then E3, En. Right, I can choose a basis like this. The first 2 elements are A and B. Well, then we have the dual basis, E1 star, E2 star, En star, dual basis. Okay. And then we do what? I'll apply the same trick here. I will just hit this identity. I will hit this identity with this basis elements. Okay, now let phi be the linear map given by phi b ya da şöyle diyeyim. Okay, D1 tensor D2 ne demiştik? İlkine buluyoruz değil mi? Which vector should I choose? Well, I can choose, for example, this one. Okay, let me write it this way. Phi E1 star, because for any covector, I can choose one such linear map, right? Let me choose the one, E1 star. So E1 star is this one and gives us E1. This gives us a scalar, and then I just multiply the second vector with that scalar. Okay, then, so let's just apply to this gadget. So I apply this to this one. Okay, now, what is this? When this is applied to this one, I get just E1 star applied to A times A, E1 star applied to B, and E1 star applied to B, W. Well, A is just E1, right? And B is just E2. E1 star E1 is just 1, so this is 1 times A plus E1 star applied to E2 is just 0. And this is some number, right? So let's say C1 times, okay, let me write E1 star E times W. So what we see is that A is just E1 star EW. Okay. Well, actually, since this is not 0, right? I am given that A is not 0. This coefficient cannot be 0. Therefore, I can just even write W is equal to 1 over E1 star E times A, right? Because since A is not 0, since this vector is 0, this cannot be 0, this cannot be 0. So I can just write this. And then we do what? Well, we can do play the same game, but this time for with phi E2 star. Similarly, well, this is just E2 star A, E2 star B, E2 star U, W. Well, E2, this is E1, this is E2. This time this is 0, 0 times A plus, this is just 1 times B is equal to E2 star of U, W. So from this, we see that W is equal to, again, B is not 0. Therefore, I can write W as 1 over 2 star of U times B. Well, B is equal to this guy and this guy. So they are equal. Now this means what? 1 over E1 star of V A is equal to 1 over E2 star of B B, and from this we see that A is equal to E1 star B over E2 star B B. So A is a, right, this is just a number, a lambda. So A is equal to lambda times B. Therefore, A and B are linearly dependent. And that's a contradiction, right? Which is a contradiction. Why is that? Because I assumed here that A and B are linearly independent, right? We assume that they are linearly independent, but we saw that they are dependent. So that's a contradiction. And the reason we arrived at that contradiction is this assumption. Hence, A and B are linearly dependent. Yes. Evet, yani linearly independent olduğu için onları bir basis'te tamamlayabiliyorum. Bu zor bir soru. Tamam mı? Bunu sınavda ancak bonus olarak sorarım. Bunu yapana da direkt A verir. Evet, hani ama şimdi siz yaparsa. Tamam mı? Bu zor soru. Ama dikkat ederseniz hani bilmediğimiz hiçbir şey yok. Diyeceksiniz ki işte böyle bir şey kullanmayı nereden akıl edeceğiz? Daha önce yaptık. Yani o yüzden de işte ne yaptık bakacaksınız edeceksiniz. Sınavda tabii bunu yapamazsınız ama ödevde değil mi? Günlerce uğraşıyorsunuz. Yani o zaman yapacaksınız. Tamam mı? Yani matematiğin içinde tabii ki bir yani matematik yapmak için bir yaratıcılık tarafı var. Ama onun ortaya çıkması için işte çok çalışmanız lazım. Yani herkes de var o taraf. Ama tanımları vesaireleri falan böyle iyice özümseyeceksiniz. Bol bol egzersiz yapacaksınız. Ondan sonra onlarla böyle kolay oynayabilir hale geldikten sonra siz kendiniz de bir şeyler üretmeye başlarsınız. Ama ilk önce elinizin ona alışması lazım. Yani şey gibi, bir müzik aleti gibi. Eliniz alışmadan çalamazsınız. Önce eliniz alışacak. Ama günlerce alete bakın. Ondan sonra hadi çal. Olmaz o. Elinizi alıp uğraşacaksınız. O yüzden hani böyle işte egzersizlerle falan uğraşmanız gerekiyor. Tamam mı? Okay, let me write down some problems and work on them. At the end of the second hour, I will give you one example where tensor products are used to solve a geometric problem. Actually, it's a very important problem. It is asked by David Hilbert in 1900, so like 120 years ago. He gave a list of problems. I don't know how many, but and he said, okay, these are the problems we will study in the next century. And soon later, his student solved one of them. Okay, of course, this is kind of embarrassing, but that student was Max Dan. He solved one of the problems, and he used tensor products. Okay. And I'll talk about it. Okay? And you'll see why they are useful. Okay. Second, okay. Consider the linear map. Let's say a hat from R5 into R3 given by ahead. Okay, but let me use X, Y, Z, T, and U. Okay, 5 methods. So suppose this is like this. X plus Y, X plus Y, or okay, 2X plus 2Y, and then Z minus P, Z minus P, and P plus U. Right. Okay. All right. Okay. Suppose it's like this. Question is this: find. Okay. Determine kernel A and image A by finding basis order. Part B is express this A head and A head transpose as tensor products as tensors. Right? Neyi bulacağız? Renkli
For the basis.
yani renk zaten şey işte sayısı olacak değil mi? Hı. Okay, so let's start with the okay. So that's the problem. We went from R5 to R3 given by this formula. We would like to determine kernel and image by exhibiting basis for them, and then we will express A transpose as an okay solution. Okay, so let's start with kernel A head. So kernel A head is what? It is the set of all vectors such that A head X, Y, Z, T, U is equal to 0, right? Well, this is 0 means X plus Y, 2X plus 2Y, and Z minus T is equal to 0. So, this gives me X plus Y is 0, 2X plus 2Y is 0, and Z minus T is 0. Well, these are the same equations, right? Yani bir şey söylüyor, sonra onu bir daha söylüyor. Biz bir kere söyleyince genelde anlıyoruz. O yüzden bir kere söylemeye gerek yok. This gives X equals minus Y, and this gives Z equals T. So, if a vector is in the kernel, then it should satisfy these two conditions. Well, then we can just write this, right, to determine the kernel. X, Y, Z, U. If this is in the kernel of A, then we know that X equals minus Y or Y equals minus X. You can use either of them. So X, and then instead of Y, I can write minus X, and then I have Z, and then T. T is just Z, and then I have U, right? There is no condition on U. Z. Yeah, I wrote Z. Tamam mı? Ne oldu? Efendim? Niye? Ne olursa olsun. Zaten onu geçmiyor ki şu anda. O ne olursa olsun. O sıfır değil. Şimdi şunu yapacağım. I will just separate the variables. So 0, 0, 0 plus 0, 0, z, z, 0 plus 0, 0, 0, 0, 0. So this means what? This is just x times 1 minus 1, 0, 0, 0 plus z times 0, 0, 1, 1, 0 plus u times 0, 0, 0, 0, 1. So what we see is that anything in the kernel is a linear combination of this vector, and this vector, right? So we see what? Hence, these vectors, what, minus 1, 1, 1, minus 1, 0, 0, 1, 1, 0, and 0, 0, 0, 0, 1 depends kernel F, right? Are they linearly independent? Yes. Bunu normalde ispat etmeniz lazım ama artık ikinci bir term olduğuna göre hani bunu linearly independent derseniz yani gerçekten onu gösterir misiniz, gösteremez misiniz onu bilemem ama hani onu kabul ederim. Tamam mı? Yani o bir şey yapar. İlk midterm'de yapmam. Yapma yani öyle şeyler ama burada yaparım. Okay, now since so they span kernel A and since they are linearly independent, right? Evidently, so this thing 1 minus 1 0 0 0. Pardon, 0, 0, 1, 1, 0, and 0, 0, 0, 0, 1 is a basis for kernel A hat. Tamam mı? Peki, so we found a basis for kernel. In particular, what is the nullity of a hat? 3, right? So from this we can do the following. Dimension of V, which is rank of a hat plus nullity of a hat. Well, this is 5, right? 5 dimensional. I have rank a hat plus 3. So from this, we see that rank of a hat is just 2. So we know that image of a hat has dimension, which is rank of A, and that is 2. Okay. Peki ben imaj için nasıl bağlı bulabilirim? Well, for the image, I just need 2 independent vectors, okay? No matter how you find them, just gave two vectors. Ya iki tane vektör bul imajda. Nasıl bulduğun hiç önemli. Nerede?
Atıyorum 1'e 2 mesela o istediğinin R5'tin.
Tabii ki R5'te olacak. Okey. Bana iki tane vektör söyleyin. R5'te. Efendim? 2, 0, 0, 0. Öyle mi? Ne verdi bu? 3, 3, 6, 0. 3, 6, okey. Bir de 0, 0, 1, 0, 0. Öyle mi? Yani hangisini söyleseniz olur aslında. İki tane vektör istiyorum. Ne söylediğinizin önemi yok ki. Kernel'da seçerseniz zaten 0 verecek. O zaman diyeceksiniz ki başka yazın. Okay. Bunu verdiniz. Ne çıktı? 0, 0, 1. Are they linearly independent? They are in the image and they are linearly independent. Therefore, they form a basis. Right? Since are in image of a and they are linearly independent. This thing 3, 6, 0 and 0, 0, 1 is the basis for image of everything. Yani imajdaki her şey bu iki vektörün linear combination. Tamam mı? Anlaşıldı mı? Any questions? Okay, so what about the final part? Şöyle değil mi? Önce şunu silene kadar. Okay, we need to write down tensor expressions for the operator A hat and its transpose. Let's start with A hat. I can write, of course, you know, millions of different ways of tensors to represent A. How? So this has no, you know, canonical answer unless you specify. For example, I can do this. I can just compute this on basis elements. What is E1? E1 means 1, 0, 0, 0. So what is this result? 1, 0, 0 koyarsanız ne çıkıyor? 1, 2, 0. So this is 1, 2, 0. What about this digit? So 0, 1, 0, 0, 0. 1, 2, 0 gene değil mi? 1, 2, 0. Efendim? Bu yanlış bir şey değil ki. Niye itiraz ediyorsunuz? Olsun yani. Ahenk 0 ve 0 transformasyonu olabilirdi. Her şey 0 çıkabilir. What about E3? 0, 0, 1. 0, 0, 1. What about E4? 0, 0, minus 1, right? And E5, 0, 0, 0. Okay. Now I can call this vector, for example, V1, or let me say W1. This one W2, this one W3, W4, and this is just 0. And I can write this with so as a tensor if it eats E1 and gives us W1. So W1 tensor E1 star plus it eats E2 and gives us W2. So W2 E2 star plus it eats E3 and gives us W3. W3 E3 star W4 E4 star. I don't have to write this one because it is already 0. So if I write 0 here, it will give me the 0 answer. So that's the 0 vector. I don't have to write. So this is one way of writing A as a tensor. Is this the most economical one? We have seen a theorem which tells us the following. A linear transformation can be written as a sum of how many terms? As many terms as its rank. What is the rank of this? 2. So I can write this using only 2 terms. How? Well, first of all, look at my basis here. For the kernel, right? This is the basis for the kernel. I don't have to use these vectors because they are already mapped to 0, right? So I need to choose a basis for R5 which contains these vectors so that I will not use this one. So şöyle diyeyim, yok, pardon. A hat can be written as a sum of rank of a hat, which is 2 single terms. How we need to extend the basis aslında fazla çalışmanızı da gerek yok. So I will write a basis for R5 taking these 3 vectors as first 3 elements. So they are linearly independent, therefore they are no, this is 1 minus 1, 0, 0, 0. And then 0, 0, 1, 1, 0, and 0, 0, 0, 0, 1. I need 2 more vectors. How can I find 2 more vectors? Well, those 2 more vectors are just actually the vectors you use to obtain a basis for the image. So I can just actually use these 2 vectors, right? So 1, 2, 0, 0, 0. METU sorusu 0, 0, 1, 0, 2. This is the basis for R5. Niye basis? Çünkü ilk üçü kernel'ı span ediyor. Bu ikisi de bunların imajı da imajı span ediyor. O yüzden bunlar linearly independent. Biz bu fikri nerede kullandık? Rank nullity'nin ispatında kullandık. Okay. So, follows from the proof of rank nullity. Orada da tam bu fikri kullanmıştık. Kernel'ın bazını aldık, sonra onu extend ettik bir basic'te. Sonra dedik ki extend ettiğimiz o vektörler, extend ettiğimiz vektörler imajın bazı. Burada da aynı şey. Bunlar extend ettiğimiz vektörler imajın bazı. O zaman bu bir basis. Tamam mı? Well, okay. This element is mapped to 0. This is mapped to 0. This is mapped to 0. So I just need to concentrate on these two vectors. Let me call this one V1 and this one V2. What is a head V1? Well, we already computed that. Ona isim de verdik. Right? Yok, verdik mi? 3, 6, 0. Let me call it W1. A hat B2. 0, 0, 1. Let me call it W2. Okay, let me say U1, U2. U1, U2. Okay. Now I can write a head then. A head what? A head is this. I don't need to use this vectors because they are sent to 0 vector, right? If you write as a cancel here, the second part is 0, so something cancels 0 vector, that is 0 element. You don't have to write that down. So I can just use this 2. So this is just U1 answer, V1 start plus U2 answer, V2 star. Okay. What about this? Is a correct answer. This is also a correct answer. This is not wrong. Okay. Olur, olur. Tabii. Transpose ne? We just interchange these two, right? Canonical isomorphism. Something you like a lot. So it is this. Okay.
So we need to verify that they are really,
They are what?
they are really tensor representation is linear map. In the example.
No, I mean, once you wrote this, you can just write down this.
That, for example, if write x, a hat x and it's equal to something which we want, then as the outward linear map. So we need to write this thing. I mean,
No. This is enough. Neden? Any linear map is determined by its action on a basis, right? I have a basis. This is the basis. This tensor and this linear map agree on this basis. What is it? A hat is 0 here. Well, this is also 0 because you know this is the basis, but I just have use only V1 star and V2 star. So V1 star and V2 star will give me 0 here, 0 here, and 0 here. So this tensor is 0 on these 3 vectors. And A hat also the same. And then this tensor sends V1 to U1. Well, A hat does the same. And this tensor stands B2 to U2. And A hat does the same. So A hat and this tensor acts the same way on this basis elements. Therefore, they are the same. Okay? You don't have to verify it. Unless I ask specifically. But if you write this much, that's fine. Anlaşılmayan bir şey var mı? Zor muymuş? Efendim? Olur, tam 30 olmuş. Evet.